Hello everyone, welcome to my YouTube channel. Today we are going to be working on this Phillips Sonicare toothbrush. This one specifically is the Costco model. You could get it at a 2-pack in Costco about 5 years ago. So it is a more basic budget model, but it was very popular because it was sold at Costco. The model number on it, HX6240. It's a 6200 series. There are a couple different slight variations on this unit, but they all have roughly the same internals, and they're all very, very similar to disassemble. So to get started, let's talk about the tools that we're going to need. There are really 3 sections to these tools. Section number 1 is just a couple little metal spudgers. There's some plastic clips on the inside of this that are kind of hard to get apart. And then a T8 screwdriver. So this is a Torx head. It's the 6-headed star. And there's just that single screw down here at the bottom. And then once it's apart, we have this section over here. This is a soldering sucker tool, just a vacuum sucker. Which is really helpful for desoldering components. If you don't have this, there are a few other ways to do it, but this is by far the easiest. I also have some solder wick, which is useful if the solder sucker doesn't get every last bit of solder to desolder the battery, because it is hard soldered to the circuit board. These clippers are just, useful for clipping things. And then over here we have this is a cheap Amazon unit spot welder that I mainly use with 18650 batteries, but it is going to work just fine with these AAA sized batteries that are nickel metal hydride. That is one of the weird things about this toothbrush. It is not a lithium ion battery. It is these nickel metal hydride cells, and the original battery comes with 2 cells that are already built together in a pack, and you can buy replacement packs already soldered together, built with just some thin nickel stripping, which is what this is. However, from all of the research I've done and all the reviews I've read, those packs have just garbage quality cells in them and often don't fix the problem of battery life, which is why this battery is getting replaced. When I got this new, it could go almost a month before needing to be recharged, and now it goes maybe 3 or 4 days. Now I have had it for I think 6 years, so that is really impressive performance from the batteries that are in here, but they are just old and need to be replaced. So rather than getting a pre-built unit with bad quality cells, I did some research to find the best reviewed and highest quality, just standard nickel metal hydride AAA cells that I could find, and then we're just going to internally fuse them together with this nickel stripping and the spot welder to remake the pack that was in it. So that's what we're going to do today, and first step is just opening up the toothbrush. So like I said, it's a T8 bit, and it's just this single screw down here. You spin that off. It does come out. There is a little rubber gasket on the bottom of this screw for waterproofing. It is held on there pretty tight, but just make sure that that's there. If it falls off in the installation or replacement, you do lose the waterproofing of this device. And then this bottom plate, you can just wiggle off. It also has a gasket, just a little O-ring that seals it to the plastic body. And then you'll want to pull the head off, because that this whole motor stick vibrator assembly will come out with the circuit board and battery and everything else. So that needs to be pulled off as well. And then here comes the tricky bit. So this plastic casing right here is the little coil for the wireless charging, but beneath it, you can see on this side there's a tab, and on this side there's a tab, and they are clamped in place. So one sticks out this way and the other sticks out this way, and they clamp into the side of the body. So they are a little annoying to get out. What I've found works best is if you can get, some sort of plastic spudger and just push down in, wiggling it a little bit just to get that clip detached from one side. You see that now it's tilted, so this side is still attached, but this side right here is detached. And then the tricky part is just keeping this side detached while you unclip this side. The way I've found that's easiest to do it is if you just keep a finger in here, applying pressure upwards, it will keep this side from clipping back in as you get your tool in there to detach the other side. At this point, you need to be careful not to snap this plastic section, and there are also some thin copper wires that go from the circuit board to the coil itself, and if you break those, pull those out, that obviously ruins the functionality of the toothbrush, and then you would have to disassemble it and swap the batteries anytime it ran out of batteries, rather than allowing it to be recharged through its inductive charger. There we go. Oh, dang it. I got the other side and then it popped back in. Okay. Not the prettiest, but see, now you can see those clips a little bit better. This one is actually in pretty rough shape because I've taken this apart a couple times before. But these two tabs right here just clip into the plastic sides, and once they're done, this entire assembly just slides right out. So right here we have the motor, vibration unit. There is a rubber gasket up here. You'll want to make sure that's just nice and clean before you reinstall it, so it reseals when everything is done. They do supposedly sell replacements for this rubber gasket. So if you do damage it, there are replacements out there, but it's not necessary to replace it as long as it's in good condition. So on the back side, like I said, we have the motor vibration assembly. There's this little plastic case that goes over the battery, which we'll take a look at in a moment. And then on this side, we have another little plastic case. And these are both made of a soft, like a polyurethane or some sort of rubber for the vibration damping of the circuit board and the battery. There are a couple different models that will use this exact same circuit board. What we're doing now is this solder piece and this piece. Those are your two battery contacts. So that is ultimately what we will need to desolder to be getting this battery out. As you can see though, like I was talking about earlier, the battery itself is... Oh, that was scary. I just turned it on. Yeah, fun fact, if you set it down on its button, it will turn on. If you peel this sticker off so we can see the battery better, you see it's really just two of these cells put together. And then there's just a little strip of you know, nickel plated copper or just pure nickel on this side, fusing them together, and then 2 small nickel strips, one going from this terminal down into the circuit board, and then the other from this terminal down into the circuit board. If you look on the side, I don't know that I can get this close enough for you to see, but that right there is where it goes through and makes that connection. At this point, we just need to fire up the soldering iron and desolder those 2 pieces. I highly recommend you get a good quality soldering iron that has temperature control, replaceable tips. The exact tip size doesn't matter for this, you know, just a generic pointed tip works just fine, but having a proper soldering iron is an absolute game changer in any sort of electronics repair. And adjacent to that, having one of these little copper sponge ball things for cleaning the soldering iron tip is also an absolute game changer. Soldering used to be awful, and now I actually enjoy it. So what we're going to do is we just heat up this first joint. And actually, I'm going to try and set this on something so it doesn't roll around as much. Yeah, that's better. We just heat up the first solder joint until it is nice and molten, and then you use that little suction thing. And as you can see, or maybe as you can see, what used to have a whole bunch of solder on it, actually, I'm going to try and focus this so you guys can see it better. As you can see, this point right here, there's no solder in that hole anymore. It's just an empty void, which is lovely because it means that this little metal tab that goes down to the battery, we will be able to pull out. Whereas on this other side, it still has solder on it. So yeah, having a solder sucker, it's absolutely amazing. You can get them really cheap, just a couple bucks on Amazon, I think. If I can figure out how to do it, I will put a link to the one I use in the description. I guess I hadn't really thought about doing that, but that would probably be helpful for you guys. So we'll just do the other one. And yeah, as far as links in the description, this battery that I'm going to be replacing it, I actually got these in a pack of 8 for like $7. So it was cheaper than what the replacement batteries cost anyway. Now granted, you do have to be able to make your own battery, and I already had a spot welder and soldering iron, but you know, if you're doing this repair by yourself, chances are you already have at least some of that. So we just get this nice and warm liquid, suck the solder out of it. So a little bit more that we want to get out. Okay, clean off the soldering iron tip. And now with those 2 desoldered, just, you know, kind of push on the back side right here to get the battery tilting a little bit. Definitely don't push on it with metal. That would be silly. Use a plastic spudger of some sort. And also, just general safety. I keep pointing to things with this, but, you know, metal tools and circuit boards generally don't mix. I've already inspected this circuit board and know what things are around here and know what not to touch. And this whole thing is very, very low voltage anyway. So it's not dangerous for me. It could be dangerous for the circuit board itself, though, depending on what you short out. So always be careful of that. This side is coming out. There we go. Now we can see the battery a lot better, and it really is just 2 independent cells in series, joined together on one side with a little nickel strip, and then these 2 nickel strips on the other side just point down into the circuit board. So we will be replicating this with these 2 cells. As you can see, they are the exact same size. It is the same size of cell. The difference is this is just in a 2S configuration, and this one is not yet. One thing to note, the polarity does matter. So, you know, in this one, this is the positive one and this is the negative one, and they're pointing up. If we switch that around, then we would have a negative voltage going into the positive terminal on our circuit board, which is not ideal. And I am going to try and duplicate these little tabs out of this nickel first, because I'm confident I can make that. But I'm going to try and do these and get those soldered first, so they're pointing up and pointing the right way, so that I can get this one done. So we'll just snip that down, and then let's see, how thin does that need to be? That's pretty thin. Let's see what I can do. Doing something like this honestly might be easier with scissors. I'm not actually sure the best way to cut this nickel strip, but it is not cutting as well as I thought with these snips. But that's okay. It'll get the job done. This might not be the prettiest. Just don't tell anyone that the battery tabs in my toothbrush are ugly, and we will be all good. There we go. We have one very crudely made tab. It is a little thicker than the other tab, but based on the size of these holes, it looks like it will still fit. Yeah, so we'll be good. So there is terminal 2, and this little strip, hey, what do you know? That very conveniently serves as our third strip. So like I said, I already had this little, you know, such a cheap spot welder on Amazon for small battery cells. I've used a couple different ones in my time. This one works okay. None of the ones I've had have worked super well, but I don't, you know, build battery packs in any large quantities. So we just get it lined up and get this tab on top here. I didn't think about this, but it would probably be helpful to have something that can hold this vertical. There we go. That looks like a lot better connection. And I will be the first to admit I'm not stellar at spot welding these small cells. Okay, so now we take the other one with the tab that's even smaller. How exciting. And hold it upright. Oh, this one's a lot easier because it has the flat bottom, so it will stand up on its own. There we go. Yeah, pro tip, press down hard on the nickel strips, because if you don't, it does not do a very good spot weld. So that's good enough, but now I have to check, yes, that is the right orientation. So I want these things to all be sticking up, and positive right here is on the left, negative is on the right, and then we're just going to flip this sucker over and get this tab to stretch over the both of them. Moment of truth, the last weld, if we can just get this nice and tight. Dink. I would definitely not call this good enough if this was in like an e-bike or, you know, anything that was safety critical, but I do think this is good enough for a toothbrush. And then this, you would basically do the same thing in reverse. You just have to get these tabs sticking through the holes in the plastic right there, and the battery clipped into place. This is a little more challenging when the tabs are short. I guess in hindsight, I should have made the tabs on this side a lot longer so I could fish them in even before the battery was clipped in, rather than trying to clip the battery in and get the tabs lined up at the same time. The things you learn. See, this is why I'm videoing this, so other people know what not to do. It does help if you have short leads like I do. If you bend them out a little bit, then you can, kind of slide them along this red backing wall, or I guess whatever the color of the plastic is in your toothbrush, just to get them aligned. Okay, took ages, but I finally got those tabs pushed back into place where they need to go. So last thing we need to do is just solder up these tabs into their positions so that they make electrical contact with the circuit board, and that will be it. And then we can just start reassembling everything, which is a piece of cake because it's only one screw, and these clips clip right in afterward. So we just get, I need to re-tin the tip on the soldering iron because it is very dirty because I just let it cook for that whole time I was building the battery. And I also need to find where my solder is. There we go, I found it. Also, I can't say enough good things about super, super thin solder. No matter what you're doing, like the solder you get at, Home Depot, at like any brick and mortar store, even if it says it's electrical solder, it's gonna be too thick. Just get really thin solder. Like this is 0.6 millimeters. Like if you can get even like a 0.5 or 0.4 millimeters, it's so nice to have thin solder. Tinning the tip of a soldering iron, you just get a big glob on the end of it and then mush it around in this thing, and that cleans up the tip and allows solder to adhere to it a lot better, which makes your soldering experience easier. And it makes your soldering iron last longer. So yeah, maintain your tools, guys. Okay, I'm gonna prop this back up on its lid. Let me just heat this joint up, allow the solder to flow in. And yeah, that solder is coming out the other side, so it did make good contact with that tab. Let me get this side. Okay, so that is soldered properly. Now we just do everything that we initially did in reverse. You get these cute little covers to put back on. Let me flip them around. Ah yes, there's this little red tab sticking up and that goes in that little hole. These clip around it, so you may have to bend them on the side a little bit to get it fixed properly. And then this whole unit just slides back into this case making sure the button is up, pointing the way you want it. Also make sure you don't pinch this top gasket as you're pushing it in. And then these things, when you just push it, they just snap in place. And that's working. So we just put this cap back on, get the little screw in there, get our screwdriver to tighten it up. And we are good to go. I'll use this for the next, month or so and see what the battery life is like, and maybe make a pinned comment when that's done. But if you actually made it all the way through this video, thank you so much for sticking with me and my very awkward attempts to explain what I'm doing and my awkward attempts to actually do what I'm doing and fail at it. I promise, if you subscribe, the next YouTube video will be better in some way. So, thank you.